In the previous video, we have implemented the shooting mechanic. As it currently stands, it looks pretty decent. Now, what we are going to do before we add some effects to this, we are going to implement an enemy so that we have something to shoot. Okay, so let's get going. Let's stop the game. First of all, let's take a look at our _sprites folder in the project section. Here we have a couple of files: sprites monsters big, medium, and small. Now we are going to only utilize one of those monsters. The one will be from the medium file, and this will be the last one. So let's see, I believe this will be 36, 7, 8, 9, 40, 41, 42, 43 frames. And this will be our monster. So we are going to use this one and implement it. Of course, you can implement the remaining ones. So what we are going to do is, I have said previously that we are going to want to reuse the setup for our player. So what we can do is choose in the hierarchy our player. We can press Ctrl D and we should have a player duplicated. Now we can use the move tool in the scene view and move our duplicate of our player. And we are going to want to go to the hierarchy. Let's rename it to enemy. Great. I believe that the sprite the last monster is called Chart. So we are going to add enemy Chart. And now what we can do is we can edit this game object. So what we can see here is that we have our agent input. We do not want that because our agent, our enemy will get a different input. We can see that we have our agent movement script, and it will be working with our enemy as well, so we can reuse it. Let's choose the avatar. Now in the avatar, of course, we need to change the sprite. So let's do that right now. Let's expand our sprite medium, and I believe the first one was 36. So let's drag it here, and we have our enemy. Of course, we will need to edit our shadow, so we will do that, as well as we are going to modify the animator, since now we have a different animations for different animation frames for our monster. So let's start from maybe implementing the animator before we play with the shadow. So what we want to do is we want to check that the animator takes a player animator script and it is tied together with the agent animations. So as you might recall, let's open the script up. Great. And now we can see that we are using walk parameter here. Of course, we could have multiple different settings here, multiple different parameters for our animator. So if we want to reuse those, we have a way to do so. So let's go back to Unity. So what we can do is we can go to our project section, _animations, choose our actually create, right click, create, and we are going to choose animator override controller. Let's call it enemy animator. Enemy animator will have the same fields, so walk field in itself, and it will have the same layout in the animator as our player has. So it will be exactly the same, but we are going to substitute the player idle with the enemy idle and player movement with enemy movement animation, and it will all work using this walk parameter. So we are not basically going to need to recreate this setup. So it is very useful for when you have a more complex setup in your animator. Okay, so again, let's go to the project section. Let's choose our enemy animator. And in the inspector, you can see that we can now provide an animator controller to override. So we are going to simply drag our player animator. Okay, and you can see now that we have two spaces that original were player idle and player movement, and we need to provide override animations for it. So first of all, let's go to the hierarchy. Let's choose the avatar, and let's drag our player animator in place of the enemy animator in place of the player animator. Let's choose the enemy avatar, and we are going to open up the animations window. If you don't have it, you need to go to the window and animations and choose the animation or animator depending on what you want to open. Great. And since we haven't overridden those animations, the old one will persist. So this is our heroine instead of our enemy. So what we will need to do is we will need to create two animations. So let's do this in our project section in our underscore animations folder. Let's right click, create new folder called enemy. And let's create a new folder called chart, since this is our current enemy. Okay, and here we are going to right click, create, and we are going to choose animation, and let's call it enemy or maybe chart idle. Okay, and let's create another one, right click, create, again the animation, and let's call it chart walk. Great. Now what we can do is we can go to our underscore animations folder, choose our enemy animator, and choose the animation clip, and we are going to choose for the idle clip, we are going to choose chart idle, and for the player movement, instead we are going to choose chart walk, or we could rename it to chart movement. And now if we go to our hierarchy and choose our avatar, we can see that for the enemy, we can see that our animations are now chart idle and chart walk. So what we can do is we can choose our underscore sprites folder, find out our sprites from index 36, 37, 38, 39, and those are our idle animations. So I'm going to select them and drag them into our chart idle. Again, I'm going to drag our 36 animation, so the first frame, to achieve this smoother animation. And now we can press play. It is playing too fast. So let's select all of those frames and let's drag them around 0.22, something like this, and let's try playing it. And you can see that it looks pretty good. Great. Now for a bit of a challenge, give it a shot and implement the chart walk animation however you can. Of course, this consists of dragging the appropriate frame into the chart walk, dragging it across the timeline so it looks good, and then adding the event, since you might recall that if we go to our player and go to our avatar and choose the animation for it, the player movement, we have those events that call player step sound. Our enemy chart also have the agent step audio player, so we can as well call this method here inside our enemy chart walk animation. So give it a shot and we are going to implement it together in a minute. Okay, great. I hope you are successful. Let's check. I think we have 36, 7, 8, 9 is the idle, and 40, 41, 42, 43 is the run animation. So let's drag it into our chart walk. And let's see how it plays. A little bit too fast. Let's drag it. Okay, we have first step, jump, step, and we have no more animations. And what we will need to do is we will need to go to our animation with index 40. So let's drag the frame 40 here, and now it should look better. Step, okay, and there will be the same animation there. Great. Now we can select those and let's drag it around, I think 15 or 20. Let's play it. And now our animation is being played, our chart is running. So this means that we have successfully implemented this animation, and now we need to implement the step sound. So let's stop the animation and let's see where we are stepping. So let's drag our timeline and let's see, here is the step and here is the step. So they are pretty close together, so we are going to implement here a step, and let's choose the inspector, and we are going to choose play step sound, and we can add one at the beginning, play step sound as well. So let's create an event using this button, and let's add to it our step sound, play step sound. As you can see, we have many more methods now, because we now have the many more methods that are public in the scripts that are dragged onto our avatar. Since our animator takes all the methods that can play from the scripts attached to the avatar or the game object that the animator is attached to, and it can play all those public methods. Okay, so if we now press play, we can see that it is playing. And before we test our animation, Let's go to our underscore animations under our enemy under our chart, and let's choose the animations and make sure that we check that they loop. Okay, and now if we press play, we should see our enemy being animated. Great, and we can enable walk. And I don't think we can because we are calling this to animate idle and to disable walk through the agent movement script. So we can't really play it. We can disable agent movement, and now I believe we can make our chart run. And now it sounds pretty good. Great. So this is our animation for our enemy. Now, before we go any further with how our enemy works and how it moves, I would like to add the logic so that our player can shoot our enemy, since this is the most important thing. But before that, let's quickly delete the weapon parent, since our enemy will use a bit of different logic for attacking, since I do not predict that we are going to want the enemy to swap weapons, and we are going to delete the point light. And now we should be good to go. We have our avatar and movement controller, and in the next video, as I have previously mentioned, we are going to make sure that our bullets can actually collide with our enemy. So see you in the next video. In the previous video, we have created our enemy that is animated, but currently it doesn't make any sounds and we cannot really hit it. So we want to change it. Before that, let's discuss a bit how our enemy will act. So the idea behind our enemy is that we are going to have a big circular area around our enemy, which will be the detection area. And our enemy, when seeing the player inside this area, our enemy will check the distance between player and start chasing the player. If the distance is smaller than the attack range of the enemy will perform the attack, which will be followed by a short delay between the attacks. And our enemy will stop following our player if our player exits its range of detection. Now this is a very simplistic system, but for this system to create it, we are going to use state machine pattern, which will allow us to decide what should happen next and what should happen depending on the decision. So for example, the distance decision or the decision of if the player has entered the detection circle. And our setup hopefully will give us the possibility to implement different behaviors like wandering idly while detecting the player, waiting for the player, or shooting at the player instead of melee attacking. So hopefully with our setup we will be able to implement different behaviors. Okay, so now with this out of the way, let's talk about how we can make our enemy receive some damage and collide with our bullets. So what we will want to do first is we are going to choose our enemy chart from the hierarchy, and we are going to first of all want to change its layer from the player layer in the inspector to the enemy layer. And we do not want to change the layers of our children. I want only this enemy chart object to have this layer. So I will choose no, this object only. Now again, we will need to move to the movement collider, and let's choose instead of the player movement collider, the enemy movement collider. This will be important because our enemies will collide with each other, so they will not be clamped on top of each other. Rather, what can happen is that our enemies will stand like this, and this will be the most that can happen, so that our player can distinguish between those enemies that there are two enemies. And if we want to have a bigger area between a bigger distance between those two enemies, all we need to do is increase this collider on our movement collider. So to make our enemy vulnerable to the bullet hit, what we will want to do is we will want to add a collider to our enemy chart game object. So let's choose our enemy chart, let's add component, and let's type capsule, and we should choose capsule collider 2D. And we can change the size of this collider depending on how you want it to behave. I want to increase it a bit, so I'm going to change the size on X a bit, okay, and change the size on Y, so we can have a more an easier time hitting the enemy. So one of the more important aspects of designing a game is to make sure that our player is challenged, but not to the point where the player wants to quit. So one of the options to do this is to increase or decrease the collider. So the smaller the collider, when you shoot the enemy, will hit the enemy. So if we make a bigger collider, it will be much easier to kill the enemies. So we can compensate it with implementing much more enemies into the scene, and then we can balance this gameplay so that player has fun time killing the enemies. So they are maybe 1 or 2 shots per kill. There are masses of enemies attacking us, but we still have the advantage because we have our gun, because our gun is powerful, and I think this could make the game more fun compared to one enemy that is a bullet sponge. And we are going to take a look at the feedback that I have received for a previous version of this game, so that we are going to analyze that one of the aspects that people mentioned was that enemies shouldn't be the bullet sponges. Okay, let's make sure that we can set the capsule collider to its trigger. So we want it to only trigger with colliders. We do not want it to be a collider. And what we will want to do is let's go to our scripts folder, to our weapons. Let's open up to our regular bullet so that we can check if we can collide with our enemy. So let's open the script app. Great. Now we have already implemented a couple lines of code here to our on-trigger enter event. Let's duplicate this check for the collision layer, and we are going to call else, paste it, and let's choose the collision game object layer, and we are going to check against the enemy. So let's type enemy, and let's create a private void hit enemy. Now we are going to create a more sophisticated logic here so that we can implement a different ways that our enemy are affected by the bullets, but we are going to also want to have a default logic. But for now we're going to debug.log and we are going to type hitting enemy. Okay, great. Now let's go back to the Unity. Great. Now if we press play, we should see some debug.log statements. You can see that we are hitting, and apparently we are hitting the obstacle. So what's going on here? I have typed twice the hit obstacle instead of the hit enemy. So I'm going to type hit enemy. Save it. We'll go back to Unity. And I'm going to stop the game and restart it. And in the next video, I'm going to show you a quicker way that we can iterate over the game. Okay, great. Now we have our hitting enemy message printed. While when we hit the obstacle, we have our hitting obstacle message printed. So that's a start. In the next video, we are going to implement some logic for our enemy so we can destroy our enemy on a hit. And I'm going to show you a neat little trick that we can speed up the way we are restarting and starting the game. As you can see, now I need to wait a bit before our game starts. So we are going to tackle those things in the next episode. See you there. In the previous video, we have implemented a way to make our bullets collide with our enemy. So we can now display a debug.log statement hitting an enemy. One issue that we are having is that if we want to restart our game, it takes a bit of time, so it might start to get annoying. So in Unity 2020, Unity has introduced a neat little experimental feature. So we can go to the top menu, to the edit, choose the project settings, and in the editor tab, we can slide it down, and here is enter play mode settings, enter play mode option experimental. If we check it, there will be a bit of a speed up when we start the game. You can see that it immediately starts and stops. But there is one downside of it. Mainly if we have static variables, so the variables that are set once per class, Unity doesn't reload those classes. So if we are, for example, counting something in a static class and we have increased the count, when we are using this option for the editor to the play mode settings, we will not reset this value. So but every time that you want to start it, there is a way to reset those static variables, but we do not have any static variables in our project, so we are not going to use it right now. But for now, for our project, this speeds up the process very much, so we are going to use it. If by any chance something crashes in your Unity, because do mind that this is edit project settings, and here is the description experimental. I have tested it a bit and it works fine, but if you experience some problems, just disable it and use the standard version. Okay? Now, the second task for this video is to implement a way to reduce the health of our enemy and to destroy it on hit. What we will want to do is we will want to create a separate script that will take care of it. But to do this, we are going to also create a neat little interface called iHitable that will help us greatly detecting if what we have hit can be hit. So the scripts in the scripts folder, let's create 2 new folders. So right click, create. One will be enemy or enemies. So those will be scripts that regard the enemies. Click create a new folder and let's call it interfaces. And those will be interfaces that we will use across the project. Let's enter the interfaces folder. Let's right click, create C# script, and let's call it iHitable. Let's open this script up in Visual Studio. Great. We are going to remove the update and start methods. We are going to change the class keyword into interface. And we are going to delete the monobehavior inheritance. So interface is a contract that binds our class to that it has to implement a certain method or property. And for us, it will be important because we are going to check if the object has iHitable interface on it. We are going to call this method. It will be void get hit, and we are going to call int damage, and we are going to call game object damage dealer. And this will be it. So we are going to simply find the iHitable on the object. If it contains one, we are going to call getHit, and the object responsibility will be to act on this hit information. So for example, for our enemy, it will reduce the health of the enemy in the custom script that we'll create soon. Now before we do that, we can create properties here. So we are going to call Unity event, Alt Enter, and we should see Unity event using Unity event events library. It will appear at the top here. Let's call it on get hit, and we are going to add get and set to make it into a property. And we are going to ensure that each hittable object has on get hit event. Of course, we could move it into our specific classes or make an abstract class out of it, but it is much easier to make an interface. But one downside of this architecture is that we are not calling this on get hit inside our get hit because this is an interface. It is not an abstract class. So you might architect it a little bit better. I have chosen to do it this way because if we had on get hit on our object, then we will know that we can call it inside our get hit, and then we can inform other classes that, for example, want to give the player feedback, visual or audio, that we want to give the player such feedback that we have hit our iHitable object. Okay, let's save it. Let's go back to Unity. Okay, and what we want to do is go to our new folder called enemies, right click, create, and we are going to want to create a C# script called enemy. And this will be the script that will drive our logic behind the health, the enemy data, and getting hit and calling. I think this is it. Mostly it will be responsible for collisions and for the enemy data storage. Okay, so let's open it up in Visual Studio. Great. And what we want to do here, let's delete the update and start methods. And we are going to add a comma after monobehavior, and let's add iHitable interface that we have created. It will have a red squiggly line, so we will need to implement the method and property that we have implemented in the interface. Since this is a contract, we need to do it. So Alt Enter and implement interface. And now we have this throw statement on get hit. We can delete those to leave just get and set, and we can add to it serialized field, serialized field. Great. So now we can show it in the inspector, and now we have this get hit method that throws an exception. So we need to perform some logic, or at least delete this throw statement here. So what we will want to do is, let's create a prop, tab. This will be prop of type int. Let's call it health. Okay. And let's set its set to be private. Okay. And we are going to add again field serialized field to expose it in the editor, because we are going to for now set it in the inspector in the editor, but next we are going to set it through the enemy data scriptable object. Okay. And let's maybe set its value to 2 by default. Save it. Now what we can do is, let's implement the simplest possible implementation. So we are going to go to the get hit method, and we are going to check health minus. If health is less or equal to 0, we are going to call on. I think we have on get hit we have beforehand. So on get hit is called here question mark invoke. Check if anybody is listening. If yes, we are going to invoke this event. And if health is less than 0, we are going to call simply destroy. And we are going to pass game object. Okay. And this is the simplest implementation. We are going to add to the script very soon. For now, let's save it. Let's go back to Unity. And you can see that I have unsaved iHitable. So I can press Ctrl-Shift-S and all the files are saved in my project. Let's go back to Unity. Great. All we have to do is choose our enemy chart, drag onto it the enemy script. We can see that our health is 2, and I can see that we can move our Unity event. So let's go back to our script, and we can go to the enemy, and let's move the event to be on the bottom of our properties and fields list. Okay, let's save it. Let's go back to Unity. Great, that's much better. Events are on the bottom of this list, so we know exactly where to look for them in the inspector. Now what we can do is, we can see that we have our health equals 2. Let's take a look at our data, at our weapon data, bullet data, regular bullet. What is this damage 1? So let's see our enemy chart. Let's press play and let's see if we can shoot it. And we are not calling this anywhere. So I have forgotten to implement this logic. We are going to double tap on this hitting enemy debug.log statement. And what we are going to do is, we are going to implement in our bullet, in our regular bullet, because here we are in the regular bullet script. We are printing those hitting enemy debug.log statements. And on collision, we are going to simply call var hittable equals our collision get component of type I hittable, and this will search for the I hittable on this game object. Now var is just a undefined type, so we are going to take the type whatever is returned to us from this line. And what we can do now is, we are going to call hittable question mark to see if we get it or if it is null. If it is not null, we are going to call get hit, and we are going to pass our bullet data, since it stores the damage data, and we can call game object so we know who has inflicted the damage. Okay, so now let's save it. Let's go back to Unity and test our logic. Okay, great, we are in Unity. I have selected the enemy chart to see its health. I'm going to press play, and let's see. The health has dropped to 1. Again, an enemy is dead. So success, we now can kill our enemy. Now it isn't very spectacular, we are going to work on it later. For now, we know that we can kill our enemies, so if we spawn multiple enemies, we will be able to kill them, but they are not going to chase us or attack us, and that's a bummer. So to start implementing some AI, first of all, we would like to have enemy data so that we will know what is the speed of our enemy and what is the damage dealt by our enemy. So we are going to start implementing this in the next video. See you there. In the previous video, we have implemented a way that we can shoot our enemy, and we have triggered or enabled an experimental option that we can very quickly enable our editor so we can test different functionalities. So it might be very useful when we go further into our game and we are constantly iterating over what we have done to see how our feedback is playing, and this can save you a lot of time. If you take a look at the avatar, inside its agent movement is using the movement data. So we want to implement a separate data file for our enemy. So let's go to our underscore data in the project section. Let's take a look at the player movement. And what we can do is Ctrl D to duplicate it. Change the name from player to enemy chart. Movement data. Okay. Next, let's take a look at the max speed and acceleration. And what I would like to do is to decrease those. Let's decrease this max speed to 3 and acceleration to 30. We will see the difference when we implement the movement for our enemy, but basically we do not want our enemy to be as quick as our player, as in this case our player will never run away from its enemy. So this is one type of data that we will need to have. Another one will consist of the settings for the health and damage, and we do not have such data. So let's go back to our scripts folder to the data SO, and we are going to right click, create, and we are going to create a C# script, and let's call it enemy data SO. Okay, let's open it up in Visual Studio. Great. We are going to delete the update and start methods and extend not mono behavior but scriptable object. Great. Now, what we will want to do is we want to add an attribute create asset menu, and we are going to create menu, choose menu name from the tips, and we are going to add in quotation marks enemies / and this will be enemy.data. Okay, save it. And here we are only going to have 2 pieces of data. So let's type prop, tab, int, and we are going to call it health max or max health. Enter. And again, we are going to create prop, int, and we are going to call it damage. Okay, let's preset the max health to 3 and preset the damage to 1. And of course we can add some ranges to it, but for now we are going to only add to those attributes field, colon, and we are going to call serialized field, as we always do, and paste it below as well. Great. Now, if you are still wondering why are we using those properties instead of fields, it's just because if someone has access to our enemy data, we can set the set to be private. And now we are only going to be able to set it through the inspector and through the class itself, but no one will be able to change the data. So this gives us a lot of control over the how we can use our data and how to prevent others to modify our data. Of course, we are not paying much attention to it since we are only ones that are working on this project. But if you predict that someone might be able to change it, you want to set it to be private, and no one will be ever able to change the data that is saved in our enemy data SO that you set it to be private setter, to have a private setter. Okay, let's save it. Let's go back to Unity. Great. What we would like to do now is we would like to go to our scripts, enemies, and let's reopen the enemy script to add the reference to our enemy data SO. So let's open up the script. Great. So we will need to have a reference to our enemy data. So let's create it. Actually, we can create it above health. Let's create prop, tab, enemy data SO, tab, and we are going to call it enemy data. Okay, let's copy the field serialized field attribute from below and paste it above our enemy data. And what we can do is we can go down, create start method, start. And let's call our health attribute as health property equals, and we are going to make it equal to our enemy data dot max health. Great. We cannot really utilize the damage data now, right now, but we now can derive how much health our enemy has through the enemy data script. Okay, let's save it. Let's go back to Unity. Last thing that we will need to do is to actually create some enemy data. So let's go to the project section, to the underscore data, and let's create new folder. Let's call it enemies or enemy data. Okay, enter it. And we can drag our movement, enemy chart movement data to the enemy data. And we can create, and we can use enemies, and we can create enemy data. Let's call it enemy chart data, or yeah, enemy chart data. And now we can leave it as max health 3. Let's set it to be 2 because, as I have previously said, we do not want our enemies to be bullet sponges, and the damage will be 1. Now let's choose our enemy chart and let's assign our enemy data to the enemy script. And make sure that you assign your movement data in the agent movement of the enemy chart to the newly created enemy chart movement data. Great! And that's it for this video. We didn't do much visual stuff here, but we have prepared our data for the later part when we are implementing AI. So in the next video, I would like to add first some sound because it is killing me that we are not hearing any feedback from shooting the enemy, and I would like there to be some sound at least for now, so we know that we have shot an enemy. And you can already see how the lack of any feedback makes this game very dull. So we're going to implement a hit and death sound in the next video. So see you there. In the previous video, we have implemented the enemy data file. We can hear the sound of our bullet being shot, but there is no sound of the bullet colliding with the wall, especially with the enemy. We do not know if we hit the enemy or not. The bullet disappears and the enemy dies, but we are not entirely sure what has happened. So to fix this, with the very simple feedback, we are going to add sounds to our enemy on hit and on death. Okay, so let's get to it. Let's stop the game. And what we will want to do is, first of all, we will want to go to our scripts folder. And here in the base of the scripts folder, let's right click, create, and let's create a new C# script. Let's call it agent sounds. Okay, let's open this script up in Visual Studio. Great. Now, as you might recall, we have an audio player abstract class that allows us to play the sounds with a variable pitch and play them without a variable pitch, but just by default. So we are going to extend, instead of mono behavior, we are going to extend audio player. Okay, great. Now we can delete start and update methods, and we will want to have a couple of clips here. So this will work for the player as well as for the enemy. So let's create a serialized field attribute, and we are going to create private audio clip. And now we can add a couple of clips. Let's have a hit clip. Let's have a death clip. And let's have a voice line clip. Okay. So the idea is that we are going to play the hit clip when we get hit, death clip when we die, so if a player or enemy gets shot and the health is 0, we are going to play this one. And the voice line clip will be played especially for the enemies when the enemy sees us, but we may want to call this for the player when the player is in range of an enemy, but the enemy doesn't see the player. For now, we are not going to use this for the player, but we may want to use it at some points. So this is just a simple grunt for the enemy and for the player as well, because we are doing this 2D game with no voices in it. But it is better to implement something so that the character can express itself even with a simple grunt, rather than have it quiet and not say anything. So this is what we are going to try to achieve, but for now let's focus on this hit and death sound because we are going to use the script for the enemy. So let's create public void, again play hit sound, and those methods will be just as simple as that. And the hit sound we can play with play clip with variable pitch, and we are going to pass here hit clip. Great. Next we are going to create public void play death sound. Now the death sound we may want to play as is, so play clip and let's call death sound, death clip. Okay. And the voice line we can again play with the variable pitch, so let's copy the method from above and paste it, and let's change play hit sound to play voice sound, and let's call play clip with variable pitch, and instead of hit clip let's type voice clip, voice line clip. Save it, and that's it for our agent sounds script. Thanks to the abstraction that we have created earlier, now we can create those clips, those scripts very quickly. Okay, so let's save it. Let's go back to Unity, and you might have this warning that the agent sound hit clip is never assigned and will always have the default value null. Now we can disable those warnings, but the easiest fix is just to go back to our script, and what we can do is simply add to our audio clips equals null by default, and now the warning will be satisfied because we have assigned the default value to this. Save it. Let's go back to Unity. And if you clear the console, the warnings should disappear and they will not reappear about the variables inside our agent sounds. Now, what we want to do is let's go to our enemy chart. Let's extend it, and we are going to create here a new game object. So let's right click, create empty, and let's rename it to agent sounds. Okay, let's make sure that it is set to be transform is reset to be 000. We are going to drag here the agent sounds, and it will automatically add to us our audio source, so we are good to go. We can Control C the agent sounds and paste it in our player again as well. Okay, it was pasted in the hierarchy, so I can simply drag it into our player and make sure that the transform is reset. Great. And our agent, our player will as well have the agent sounds game object. Great. So now let's go back to our enemy chart and agent sounds for it. And what we want to do is we want to set the pitch randomness to something like 0.1. We want to choose the hit clip using this cog icon, and let's type impact. And we should have impact underscore 03. So let's choose this one. We have death clip. Let's choose the cog icon. We are going to choose dinosaur. And we are going to choose dinosaur 4. Of course, you can swap those sounds if you don't like those. And again, choose the cog for the voice line clip. And we are going to search for augur. And we should have augur 2. I found those to be pretty good. And we can click on those and find them in the sounds. And let's choose impact. This will be the impact sound. Dinosaur. And this will be the death clip. And voice line will be this augur 2. So this would be played when our agent detects our player or the player is in range, and the enemy exclaims that it is going to chase the player, so the player knows that something is going on. Now, before we can assign those sounds, let's go back to our enemy chart agent sounds, and we need to edit a bit the audio source. So what we are going to do is we are going to set the volume to be 0.4. We are going to make sure that it doesn't play on awake. And in addition to that, let's go to our player, agent sounds, and let's again uncheck play on awake, since it might play some sound if we assign to it. Okay, so now we want to assign those sounds to be played whenever something happens. And one way would be to go to the script that drives the events of our enemy and get a reference to our agent sounds and assign those play specific sound to the action. But what we have created is in our enemy chart, we have our enemy script. And our enemy script exposes the Unity event on get hit. So what we can do is right click here on this enemy script, on those three dots, and edit the script. And we have the logic here to get hit and also to die. So we are going to make sure that we have a new event on die. So let's copy the event that we have already in our file, in our enemy script. Let's paste it below. Let's rename it on die. Okay. And we are going to call this when we get hit and the health is below or equal to 0. On die ?.invoke. Now the issue that we will experience is that we are going to destroy the game object right away, so the audio source as well, and it will never play the sound. So instead we are going to create a coroutine at the bottom of the get hit method, IEnumerator, and we are going to call wait to die. Okay, and let's yield return, and let's call it for example new wait for seconds, and let's give it something like 0.3f. Maybe this is enough. We're going to create a bit of more sophisticated way to wait to die, but for now this will be better than destroying the game object and never hearing the death sound. So let's cut out the destroy game object from get hit and paste it in our coroutine, and we are going to type start coroutine, and we are going to pass here wait to die. Great. Let's save it. Let's go back to Unity. Okay. Now we can extend our enemy, and it should have two events. So what we will want to do is we will want to add to the get hit a new listener. I'm going to minimize the movement and the capsule collider. And on get hit, we want to drag our agent sound, and we want to choose the function agent sounds and play hit sound. On die, we will want to add one event listener, choose our agent sounds, and click on no function and choose the agent sounds and play dev sound. And we will want to make sure that we disable our collider. So we are going to choose the collider from our enemy chart. So let's drag here to the new enemy event listener. We're going to drag our enemy chart, choose the capsule collider 2D, and choose the bool enabled. And we are going to simply disable this collider so that our bullet will not hit the enemy, or at least they will not trigger again the death sound. And when we press play, we can hear the sound, the splash effect, and we can shoot again. And this was a bit of too small time to wait to hear the whole sound effect. So what we can do is let's choose the agent sounds in our enemy chart in the hierarchy. Let's choose the dinosaur clip. Let's select it, and let's see how long it is. It is about 5 seconds. So let's go back to our script. So agent sounds, enemy chart, enemy, click those three dots, edit the script, and we are going to set it to something like 0.53 or 0.54. Save it, and let's go back to Unity. Okay, great. Let's save the project, let's play the game, let's try it out. Okay, this was much better. So now we can hear the sounds or the audio feedback of our enemy being killed and being hit. And that is great. Now a bit of an exercise before we finish. When we press play and currently shoot our enemy, we hear the hit sound, and then we hear the death sound. And of course we are disabling the collider, so if we continue shooting, the bullets go through our enemy, but it doesn't disappear. So give it a shot and try disabling the avatar, or rather the sprite renderer, when we perform the on death event. So this is in our enemy script, inside our enemy chart game object. Try adding something here to the on die event so that you disable the sprite renderer. Okay, I hope you are successful. So it is as easy as just adding a new event, sliding our avatar here, our avatar game object, and it contains our sprite renderer, which we can of course disable by setting the bool enable. And now if we press play, we should be able to kill the enemy and disable it, and we hear the last sound before it dies. Now it isn't a perfect solution, but for now it will do. In the next video, we will take care of preparing our project to implement the enemy AI. We are going to talk a bit about how the AI will behave, and we are going to start this topic in the next video. See you there! In the previous video, we have added some sounds to our enemy, and we have explored how useful the Unity events are for adding some functionality to our logic for our game. Now let's talk about the AI setup. So our enemy will have a pretty simplistic setup, but since we are going to utilize the state pattern or state machine for our enemy, we will come to that in a bit, we are going to be able to add and expand its behavior. So basic idea will be that we are going to be in the idle state, and we are going to check player in range. So this will be the question that enemy will ask. If the player is in range, we are going to go to the chase state, and else we are going to go back to the idle, and from the chase state we will be able to go to the attack state, asking is player in attack range. And this will be the attack. And if we are not in the range of the attack, we are going to go back to the chase state, and the chase state then we will go back to the idle if the player exits the range. And attack will simply loop around itself, checking the delay. If the delay is less than the waiting time, so we are going to wait before we perform the next attack, we are going to lock this attacking state, so we are going to basically do nothing here. And if we wait a bit, we are going to unlock the attack, so if the decision that the player is in the attack range will return true, we are going to again call the attack. This will be much easier understood when we implement the code, but basically what it looks like is that our enemy has a simple range of attack, something like the circle, and if our enemy detects that the player is inside the circle, it will have some kind of range for the attack, so something like this. And if our player is in this range, we are going to perform the attack, else we are going to chase him or her in this case, and if the player exits the circle of the range, our enemy will stay idle. To calculate how we should move, we are going to simply detect if we are in the range of the detection circle. We are going to calculate the direction from the player to the enemy, and we are going to make enemy follow this direction until the player is in range or until the player exits the range of detection. And that's the basic idea behind our behaviors to drive our enemy around our map. Now this poses a question: what happens if we have some obstacle? So maybe it would be a good idea to also add some kind of a detection by shooting a raycast here and checking if there are any collisions. So this would be kind of a sight sense. So the detection range would be hearing. Okay, since this isn't the course about creating the AI for our enemies, let's take a look at the article about the state machine, so we maybe understand a little bit better how it works. Okay, so I have found this resource on the internet about the finite state machine, and we can read here that a finite state machine is a model of computation based on a hypothetical machine made of one or more states. Only a single state can be active at the same time, and basically that's the most useful information. So you can see that this is a kind of the diagram that we have created for our game, and we will see that our I assume this is an enemy, will wander around. If player is near, so this is one of the decisions that our state machine has, it will go to the attack state. Player is out of sight, it will go back to the wander state. For us, this is the idle state. So we can see that if player is attacking back, it will try to evade. Of course, there are some chances here, so if the enemy is successful, it doesn't depend on the state machine. It is rather than the event flow of what the enemy will try to do. And if player is idle, so player has the delay of between the attacks, it will try to attack back. And there is another decision here. If our enemy has evaded and the health point are low, it will try to find an aid or the health pack. And you can see that it will start finding the aid, and if it has found the aid and it has healed itself, it will go back to the wander state, and since our player might be near, it will go back to the attack, and it will happen automatically, so that we do not need to worry about going from this find aid back to the evade or back to the attack. We're going to basically use a structure such as we are using in the animator for our animations. The decisions will drive us back to the correct state. I will link this article in the description in the resource section for the video. Okay, so I hope this brings a bit of clarity what we are going to do in this section. In the next video, we are going to start creating our AI system from creating enemy AI brain script that will drive the whole action and the whole enemy AI logic. So see you in the next video. In this video, we are going to start implementing a way for our enemy, Charge, to move around. Now, in our enemy script, we have only the events of what is the state of our enemy when it comes to the health. And for our player, you can see that we have the script agent input that drives the movement of our player through getting the input from our player keyboard. So we would like to have a similar script for our enemy, but instead of using the player input, we would like to have the AI drive our enemy's movement. Now, to do that, the simplest way would be to just edit the agent input and extract all the properties, which means all the events, to an interface so we can implement them very easily and have the same structure for our enemy, so anyone that looks at the player and the enemy knows exactly that, okay, they have the same events, so that I can assign those events and I will be good to go. Let's open up the agent input from the player, or you can go to our scripts folder and open up the agent input script. Great. We are in our agent input script, and we can see that we have the private camera and fire button down bool value, but beside that we have those public events, Unity events. And now what I would like to do now is I would like to get those events and copy them to our enemy brain, enemy AI brain script. But instead of copying them by hand, there is an easier way, I think. Because if in case we want to add some more input positions here, and we want them to be added to the player and the enemy, we would like to go to the script for the player agent input and for the enemy AI brain, and we would have to modify those and add those additional events. But instead what we can do is slide up to the name of our agent input class, right click here, and we should have quick actions and refactoring, click it. And we should have this last option, extract interface. We can click it, and now we will be able to create an interface that contains all the events that we want to have in both of our scripts. This is very useful when we have a central script like an enemy or a player that ties together the events to the appropriate classes that use those events. But since we take a different approach here and we want the game designers or people that work with the editor more than with code to be able to tweak the behavior of the events, we will extract the interface, but we are not going to use it in the default way. We are going to simply use it so that we can implement those events quickly to our enemy brain AI or enemy AI brain script that we will create in this video. So the name of the file will be iagentinput.cs. This will be the name of the interface, and this will be the fields that we are exporting from our agent input script. Now, if you have any more fields, you can deselect them. I will need those 4 fields, so I'm going to click OK. Now, the Visual Studio will do its thing, and we have this agent input interface that we are implementing in our agent input. Now, we can copy the name. Let's go back to Unity. Great. Now we can see that in our underscore scripts folder, we have our iAgent input. We can drag it to our interfaces folder. Great. And what we can do now, let's enter the underscore scripts, enemies, right click, create, and let's create new C# script. Let's call it enemy AI brain. Okay, let's open this script up in Visual Studio. Great. For now, we can delete the update and start methods. And after mono behavior, we are going to add comma and type iAgent input. And now it has this red squiggly line, so Alt enter on it, and we have this implement interface. And now you can see that we have implemented all those events. Now, they are throwing errors and they do not have the attribute, so let's fix that quickly. We are going to simply delete everything beside the semicolon sign and the get, and everything beside the set and semicolon. So this will be what we want to have. Let's copy this, and we can simply paste it for the other events. But now, what we have gained is that if we want to create other scripts that will drive our enemies, we can implement this iAgent input, and we will have those events automatically implemented. So if you take a look at in the inspector, you will know that all of those are tied together for the movement script. So this is why we implemented the properties instead of fields, and that's how we can use those interfaces to make our life a little bit easier to implement the same exact names and to make sure that our classes are compatible if we want to use this iAgent input to assign to those events from a script rather than from the inspector. So now last thing that we will need to do is add the attributes. So let's create a square bracket field, colon, and let's type serialize field, and let's copy this attribute and paste it above each of those events. Great. And now we have started implementing the enemy AI brain. As I have previously stated, the enemy AI brain will be responsible for driving our AI, so doing what we have implemented for the AI to do. And this will call all those events that we will assign to the different in our enemy chart game object. Before we can expand this script, we will need to add a script to the player. So let's for now save the script and let's go back to Unity and assign those events. Great. Now what we will need to do is let's open our enemy chart, and we have our agent input script. And what we can do is we can copy exactly the same setup that we have in our agent input script that is currently disabled, and copy it to our enemy brain that we will drag onto our enemy chart. So let's do that. We have our enemy AI brain, and let's take a look what we can see. On movement key pressed calls our agent movement and our move agent. So let's do this for our movement key pressed for our enemy AI brain. So let's add here object. Let's drag our enemy chart. Let's choose the enemy the agent movement, and let's choose the move agent method. Great. Let's slide up for our AI input, and we can see that we have on pointer change. There is the agent render assigned. So let's do this for our on pointer change. Let's add here event. Let's drag again our, I think this is avatar now. Let's choose agent render, and let's choose the method called face direction. Great. For now, that's it for what we can assign. But now we can delete this agent input script from our enemy. So we can click those three dots and remove component, since we will not need it. The inspector might take some time to refresh. Basically, that's it what we will need. Okay, now we have our enemy script here, our enemy AI brain. And since we have our enemy script that stores the value about the health, what we can do is implement a similar script to our enemy script for our player. So first of all, let's now open up the enemy script. Great. And here we can see that we have health parameter on get hit and on die, which will be similar for the agent of type player and for the agent of type enemy. So again, we can right click on the enemy class, go to quick actions and refactoring, choose extract interface, and let's call it iAgent. And those will be the parameters that our agent should have. You can extend this window by dragging it by holding the edge of this window. And what we want to do is extract get hit, health, on die, and on get hit, but not necessarily the enemy data. Of course, we could create some kind of abstraction for our enemy data, so it will be agent data, but for now we do not have it, so let's extract the agent with those parameters. Okay, now we have our iAgent, and what we can do is save it. Let's go back to Unity. Great, you can see that our iAgent interface is inside our enemies folder, so let's drag it into our interfaces. Let's open up our player folder inside our underscore scripts, and what we can do is right click here, create, and let's create a C# script called player. And before we open the player script, give it a shot and try implementing iAgent interface to it on your own, and I will show you how I do it in a bit. Great, I hope you were successful. Let's open up the player script. Great. And what I would do here is delete the update and start methods, add comma after mono behavior, type iAgent, Alt Enter, implement the interface, and what we can do here is simply delete one of these statements for throwing an error when it gets the value and when it sets the value. Okay, I'm going to copy this and paste it for our health and for our other event. And I think we have extracted the get hit method, and I think it belongs to iHitable interface. So let's right click on the agent, go to the definition, and we can see that I have extracted one too many things, so the get hit method to be exact. I'm going to delete it from our iAgent script. I'm going to go back to our player script. If you don't have it opened, reopen it. And here, let's delete the get hit. And now we are good to go. So last thing that we will want to do is go back to our enemy AI brain. Maybe you have it opened in Visual Studio, so click it in the top tab of the scripts in Visual Studio. And what I would like to do is create another field here. Let's call it prop, tab, game object. Let's call it target. Using tab, move to the name, target. Enter. And underneath all those events, we are going to create awake function. And what we are going to do here is call our target equals find object of type, and we are going to type player dot game object to get the game object, since we are not sure if we want to have the access to the player or the game object, so it's better to get the game object for now, and it will be useful when we want to get a transform of it. For now, I think this will be a good solution. So that's it for our enemy AI brain. Let's go back to Unity. Okay. And let's finish the setup by adding to our player game object the player script. Let's drag it onto our player, or you can use add and type player, and you should have our custom script. And now we will be able to access the player script. And since our enemy chart, we didn't serialize it, so we are not showing if it has found the player. So we can do that by simply reopening our enemy AI brain and adding the field serialized field to our game object target, so that we have easier time debugging if by any chance our enemy haven't found the target. So let's save it, let's go back to Unity. Okay, let's quickly press play and let's see if our enemy chart is found in our enemy AI brain target, and we can see that it points to our player. So great, our enemy now knows about the player. In the next video, we will need to start creating the basic setup for our state machine, so that we can implement all those references to our enemy AI brain, so it can drive the behaviors. So see you in the next video. In the previous video, we have implemented a script called enemy AI brain that will drive our enemy so it can walk and move towards the player and possibly attack our player. Now the naming isn't perfect because it is on fire button and on fire button released, but basically this is the name of the axis that we are using. So you may want to change this, but for now we are going to leave it as is. The important part is that we want to implement our state machine so that we can drive our enemy to move around the states that we want it to be. So for example, idle state, chase state, and attack state. So let's take a look again at our reference article that we have used to learn about finite state machine. Great. Let's slide it down to what is finite state machine, and you can see that first of all we have those boxes which represents the states of our state machine. So for our AI it will be idle, chase, and attack. Now the lines that go from one state to the other have arrows, and those depicts the transition from one state to the other. And we are transitioning from wonder state to attack state and back from attack state to wonder state. And the text above those lines is what is called decision. So decision is player is near, and this should have a question mark. So if player is near, we want to move from wonder state to the attack state. If player is out of sight, we want to go back to our wonder state. So we can already see that we are going to need three representations: representation of a state, representation of a transition, and representation of a decision. And that's what we are going to implement in this video. We are going to create a basic abstract classes that will be the blueprints for our states, transitions, and decisions. And from those components, we are going to be able to create this big finite state machine mechanic, or rather this diagram. And that's why I have mentioned that our setup will be modular, and thus we will be able to expand it by other states and other decisions and other transitions as we need to with this simple setup. So let's create the setup by going back to our Unity. Okay. And what we will want to do here is let's create in our underscore scripts folder a new folder, right click, create, choose folder, and let's call it AI. Okay. So this folder will contain all the scripts that are connected with the AI. Let's open this folder up. And here we will need to create two things: the scripts responsible for the AI and the data files that are responsible for storing the data so that we can use it through our enemy AI brain, to perform the operations like movement and attack. So let's create here, right click, create a new C# script, and let's first call it AI movement data. Okay. Don't open this script up yet. We are going to create a new script, right click, create new script AI, and let's call it action data. So we are going to split our data. The movement data will be if we should move and what direction should we take. The action data will in turn tell us if we should attack or not. And of course we can add here more variables to store the data. Okay, let's create the script. Let's create three more. Those will be representing the finite state machine. So right click, create C# script, let's call it AI state. Okay. Another one will be right click, create C# script AI decision. Okay. And last one will be AI transition. Right click, create C# script, let's call it AI transition. Okay. And we should be good to go. Now, since we will not be able to create all those scripts and keep this video around 10 minutes or less, we are going to start from creating the AI movement data. So let's open this script up. Okay. And let's delete the update and start methods from here. What we are going to do here is let's create a prop, tab, and we are going to have a vector2, and this will be responsible for storing the direction which we should take to move towards our target. So direction, enter. And we are going to create a second one. Let's type prop, tab, and let's call it vector2. And we are going to move to the name using tab, and let's call it point of interest. Now, why do I call it point of interest and not the target? I'm going to use the Enter the Gungeon Wikipedia page for the enemies, and we can read the description that will give us some idea what the enemy does. So the basic enemy slowly walks towards the player firing bullets. and we can see that different enemies have different behaviors, and what we can see is some of them run away from the player and disappears if not killed. So let's go back to our script. So we can see that this point of interest might represent the player as well as the runaway point, or it can represent the position where the player was, and since the last check maybe the player has moved, but our AI has received this coordinate as a position where the player was last seen. Okay, great. So we can leave it like that, or we can expose it in the editor for the debug purposes. So maybe let's add to it field colon serialized field, a serialized field. Okay, and let's add it to the point of interest. So maybe let's quickly go back to Unity and implement the AI action data. Okay, let's open up the AI action data file. Great. Let's delete the update and start methods. And again, we can add here some props. So prop, tab, and we are going to create bool. Tab to move to the name, and let's call it attack. Okay, and we can create the field serialized field attribute to expose it. And we can create another prop, tab, and let's add bool, and let's call it target spotted. So this will be useful to check if we have found the target inside our range of the detection range. And another one will be prop, tab, and we're going to have another bool value. And let's tab to the name, and let's call it arrived. So we will want to know if our enemy has arrived close enough to the player to perform the attack. Again, we can add the field serialized field attribute to all of those parameters so we can read them and check them for the debug purposes. Great, so that's it for this episode. In the next video, we will implement the decision state and transition scripts. So let's see you in the next video.